This is this is problem number 4 from your midterm review. Now we have the same data that we used from the previous problem, problem number 3, but this time they're assuming that these are ages, and we're looking for the median Q1 and Q3. Now we know that there's 36 numbers, so if we sort this in order, we can look at half of 36 is 18, so and then 36 is an even number, so we can look at the mean between the 18th and 19th numbers. So, but for the sake of speed and trying to get the answer as quickly as possible, if you already have this in our calculators, like we do, we actually have it sorted already, so we can easily go down to the 18th number. And the 19th number. So it looks like it's 16 and 16, so then the mean between the 18th and 19th number is going to be 16. And then from there we take it to Q1 and Q3. Well, instead of doing it like that, the easiest way to do this is to go back to the home screen, hit Stat, Calc, and do a 1var stats. And we're going to do 1var stats on L1, so if you hit second function and number 1, you'll get L1. Run it. Not only will it give us all the important piece of information that I would normally be asking for, like the mean. Remember that the standard deviation that we want to report is the S, and we have n is equal to 36 there. If we scroll down to the next page, we have the minimum, the Q1, the median, the Q3, and the maximum. So we're going to use the median here. So the median is 16. The Q1 is 11.5. By the way, you would get Q1 if you take half of this, the 18, and then you find the middle of that when everything is in order. Q3 is 26.5. Alright, part B, Michael is 26-year-old. What percentile does he fall in? So he should be in the list somewhere, 26. Again, this is not going to be of any use until we put it in order. And so to find the percentile, if you remember, we need to figure out what position he's in. So it's position divided by total, and then times 100%. So we go to our sorted list. We'll hit Stat and enter, and then we'll scroll down until we see 26. So it may occur, like in this situation, that 26 comes up 1, 2, 3 times. So we'll just pick the first 26, and we see that that is in the 25th position. So here Michael is in the 25th position. This is what we are looking at, the position, not the number itself. 25th position divided by the total. There's 32 or 36 numbers total, times 100. So let's just punch that in the calculator real quick. Back to our home screen. 25 divided by 36, and then times 100 would just move the decimal place over, so it looks like we have the 69th percentile. So we'll go with the 69th percentile, and I think it's good to actually spell out the whole word If not, just do the percent sign in ILE, so 69th percentile. The next question, Hannah's age falls in the 40th percentile. How old is Anna? So this is the locator problem, where we take a look at the 40th percentile times the number of data that we have. So it's k over 100 times n. So let's punch that in our calculator to figure out what our locator is. And our locator, remember, is just a position. So we have 40 divided by 100. That's 0.4. You could just have 0.4. And then times 36. 14.4. And remember the round off rules for this. We always round up. Round up. So regardless of what number this 10th place is, we always go to the next whole number, which is 15th position. Now this is not your answer. 15 is not your answer. What you need to do is you need to go back to your list and look for the 15th position. So that's 10. So the 15th position happens to be the number 14, and so that is going to be the value that we're going to pick. So Hannah is 14 years old. Probably box your answers here. Okay, and then finally draw a box plot for the people. We have the median, the Q1 and Q3. All we need is the minimum and the maximum. So the maximum was 74. The minimum looked like it was 4. What's really important here is that we actually have a number line. Maybe go all the way up to 80, so that we have a semi-accurate plot of the box plot, because it is important to put these measurements where they're supposed to be. So this is 10, we'll say 4 is right here. So right above the number line, I'll mark my minimum 4. 74, this is 70, 74 is somewhere over here maybe. So I'll mark another line there with 74. And this line will be connected. Now the Q1 is 11, so this is 10, 11, 11 and a half will be somewhere over here. And this will begin your box. Your Q3 would be 26. So this would be 30, 26 would be somewhere in the middle. This would be your right box. So this is where you get a feel for how your distribution is going to look like via the box plot. 15, 16 is a little bit over here. And so we complete the box, label 11.5. label the median 16, and 26.5 is Q3. So here is our box plot, which by the way you can also obtain using a calculator. Let's do that really quick. Let's do a second function and stat plot. Now let's just use the first plot since it's kind of already set up. So let's hit enter. The plot is on, and the type, if you right arrow until you hit the box plot, and the box plot, it's important to note that the box plot is the one that has a median in between. So let's hit enter, and then we have the X list and the frequency is 1. X list is L1, the frequency is 1, and so we're ready to graph this. We don't need to specify the window or anything, and you can see the plot, the box plot that they have is fairly consistent. We got the median really close to the Q1, and then a big long string over here before you get to the maximum of 74. So here's the box plot, and that concludes problem number 4.